Hi Year 12, we're looking at the video solutions to the assessment task 2 for 2023 for advanced mathematics. If you have a look below, I'm just going to start at question 12 and we'll go through from there, and I'll go back to question 11 in a moment. Okay, so this one looked at the rectangle PQRS, and it has been inscribed inside the ellipse. The ellipse equation was given to you. And on the edge of the rectangle at point P, they've given that to you as X and Y. So we're in the XY Cartesian plane. And the first thing it wants us to show is the area of the rectangle being 4XY. Now there's two ways we were looking at a solution for this. You could have decided that one rectangle, so for example, one small rectangle here would be X along and Y high. So the area of that one small rectangle that I've coloured in there would be XY. And if you had 4 of them, you would have an area of 4XY. And that 4 of those areas would take that whole rectangle PQRS. So that would be one way of doing it. The other way to do it would be also looking at length and breadth of a rectangle. So area is length times breadth. And we could think of the length across here as being X and X, so we've got 2X, and our breadth or our width, we've got Y high and Y high, and we'd have 2Y, and hence we'd have 4XY. Those are two different ways that would have got you the full mark for that question, but there are other options as well that people did. Okay, let's have a look at part B now. Hopefully when you looked at this question, you would have noted that we're probably going to be looking at a maximizing or minimizing question. And the way that these questions fall are always identical. You're given one equation, and that is one of our equations there. You need to form another equation, or in this case, we've given you that other equation. And then normally you need to combine those two equations and get rid of a variable. And what I always get my class to do is to have a look at what we're trying to prove. In this case, we're trying to prove area, and we only have X in there. So that shows us that if we've got area up here, have a look up here, and both of our areas, or we only have one area actually, our area here has a Y in it. So that means, okay, we only have X below in part B. This has Y in it. I need to remove Y. So that's the variable that needs to be replaced, and the only way I can get Y is from this equation. So this equation here needs to be rearranged to find Y, and then that gets subbed into there. So you can always work out what your variable is that needs to be substituted in, because it basically tells you there in the question what one's missing from what you had above. So it's saying, hence use the equation of the ellipse, show that the area of the rectangle can also be given by this. So there's my 2X, this part's going to be my Y. So we're given this equation up above, X squared plus 4Y squared is 36. I just rearranged that, and working through the steps, I've taken off X squared, I've divided by 4, I've taken the square root of the top and the bottom, so that 4 becomes a 2, and I've still got a square root of the top. I don't want the negative. Normally when we take a square root, we do the positive and the negative. This is looking at distance, so we don't need the negative here because we don't have a negative distance. This is the value of Y that I'm going to substitute in, and then it should fall out nice and neatly. So I know area is 4XY. This goes in for Y. 4X times what I'm substituting in. It falls straight out, nice and easy. That 2 and that 4 cancel to end up with 2, and that's what we wanted. So fairly straightforward. And that would have got you 1 mark to do that. And those of you that did have a go at that did a really good job of that. Part C. We're wanting to find, or show, sorry, that dA dx is equal to this. Now, what a lot of people did is they differentiated this and found me the second derivative. That is not what I want. I wanted you to show me that this is equal to this. To find dA dx, I need to differentiate my a. So I need to have a look at this part in the question above. There's an a on the left, there's x's on the right. So if I differentiate a with respect to x and differentiate this function, hopefully I have this. And that's what I wanted to do. What you would have noticed if you did that is that you've got an x out the front here, and you've got x's underneath the square root sign. So x is happening in 2 spots. There's 2 functions with x in it, so you need to use the product rule in that case. In using the product rule, what I've done is said that this part at the front is my u, this part behind is my v, So if u is 2x, u dash, or du dx is 2. If v is 36 minus x squared, I've just popped the square root as a half. Then v dash is, and this is where people sometimes went wrong, bring the half down, take 1 off the power to get minus a half, but please also times by the derivative inside, so timesing by minus 2x. This 2 and this 2 cancel, so I end up with minus x. And what I want you to do always is rewrite this without a negative index. And I particularly want you all to rewrite that without a negative index in our maximum or minimum questions, because the more you do of these, there is a pattern and they often fall out the same way. So what I need to do is pop my u's and u dashes, v's and v dashes in my formula. You would have gotten it straight from the HSC formula sheet. I've written it like that. The HSC formula sheet has it written as v du dx plus u dv dx, but they're the same. I'm popping them in. So v times du dx goes in first, minus u times dv dx. Now, because you've written your v dash with this on the bottom line without the negative power, what you will find is you've got algebraic fractions. Now, what a lot of people did was pop this whole thing to start with over 36 minus x squared to the half. That is not what happened. These are individual parts and there's a minus between them. Now, what you will find if we're doing a algebraic fraction, this seems to happen continuously. I think in the last few years it's happened maybe 3 out of 5 HSC papers, and it was in our last prelim last year. I want to pop everything over 36 minus x squared to the half on the bottom. So I'm going to then look, well, when I do that, this is multiplied the first fraction by 36 minus x squared to the half on the bottom. So I times it on the top as well. So what I'm getting is this half and their base functions being multiplied. So I have to add the powers. So a half and a half gives me 1. So I end up with 36 minus x squared to the power of 1 on the top minus my 2x squared. And that's where most people made their mistake. Expand the top lines, gather like terms, and that's what it looks like. And I've just popped my half as a square. So fairly, I think, straightforward, but I think this is something that we need to practice a lot before we are getting into the HSC. It's constantly coming up. And moving down to D, it says, hence, find the maximum possible area of the rectangle. Now, we all know what hence means. Hence means use the information from the question before. The next information that's in that question is telling me that I'm finding the maximum, and it's going to be area. So you need to possibly highlight those or make those stand out so you're doing what the question is asking you to do, because not everybody did that. Okay, now this is fairly straightforward, okay? When we have a maximum in these questions, think back to when we were sketching our curves. A maximum, was going to look like that. It is a stationary point. So when do stationary points happen? They happen when the first derivative is 0. You have found the first derivative from the question above, and we're just letting that equal to 0. These ones fall out really nice. If I multiply both sides of this equation here by 36 minus x squared to the half, I'm going to have that bottom line disappear. Cancels out on this side, it times by 0 on this side, so I'm basically left with that top line. 72 minus 4x squared equals 0. All I've done is rearrange that, okay? Plus 4x squared to both sides, divide by 4, take the square root. Because I'm looking at distance here, or values that relate to area, I don't want plus or minus x, I just want plus. That's 72 over 4, and that's square root of that. If I simplify that down, I get x equals 3 root 2, which is also root 18. So they're the options for here. But that's not what we want, okay? That's the x. I think that was the width of the rectangle. This is asking me for the maximum possible area. So what I wanted you to do was to get that x and substitute that back into the area equation that we had a couple of questions up. I think it was part B. This one here, okay? A equals 2x, 36 minus x squared. So I would like you for that to substitute that into there. I might just highlight that for us. That's the equation there. When I substitute my 3 root 2 or root 18, depending on what you ended up with, and worked that through, I ended up with 36 units squared as my area. Okay, now that's okay to stop there, but I want you to go and test that that's a maximum, because what if that was a minimum area? Okay, so I'm going to test it, and what I like my guys to do in my class is either look to find the second derivative, or if we're looking at the second derivative and it looks too difficult to do, we're going to go and use the first derivative and test either side of our x value and see if it tells us if it's a max or min. Okay, so when we're testing either side of that x value, we're going to substitute our values for x into our first derivative, and what we will find that if we pop 4 in, we're going to get a positive value on the left. If we pop 5 in, we're going to end up with a negative value on the right. So the slope of a derivative that's positive goes this way, the slope of the derivative that's negative goes this way, so we've basically got a maximum. So then we can be assured that, yep, our 36 units that we calculated before were a maximum. That would have given you 2 marks for that question. Let's have a look at the next one. Okay, this question was, if you had a go at it, was generally done really well. A lot of people either didn't get up to this or left it because they were a little bit nervous. But what it's asking us to do is show that the function y equals kx e to the kx has one stationary point, and that the value, or the y value of the stationary point, is independent of k. Now, if you did the right method, it fell out really neatly, but what a lot of people did not look at was the function itself. Now, if you look at that function, the thing that we're looking at in here that's really important is the x. There's an x that happens here, and there's an x that happens here as well. So we've got this x, we've got this x. X is happening in 2 separate places. So there's basically 2 functions joined together. The k is a constant, okay? It tells us k is a constant. That just means k is a number. Maybe k is 2 or k is 3 or something like that. We don't know. But because the x happens in 2 spots, you need to use the product rule. I think more than half of us this year in this question have ignored this x here and differentiated, brought the k down and made it k squared x e to the kx. No, you can't do that. We need to use the product rule, okay? Otherwise, you've not done the question right and it's not going to work at all. So we need to note that. So I'm going to let u equal kx, my first 2 parts. Therefore, u dash is k. My v is going to be e to the kx, so v dash is k e to the kx. Popping it into the product rule. The product rule is on your formula sheet. You write it down and you substitute it in. V du dx, so I get k e to the kx plus u times dv dx. So the k's are going to multiply together. I'm going to get k squared x e to the kx. So now I have my first derivative. Okay. There's, again, a pattern when we get these. When we've got exponentials, generally they fall out nice and neatly where we need to factorize. So where possible, look to see if you can factorize, and you can. You can pull out a k and you can pull out an e to the x. When you do that, you end up with the first derivative looking like this here, k e to the x, k e to the kx, sorry, times 1 plus kx. Now, read the question again. Show that it has exactly one stationary point. Stationary points happen when the first derivative is equal to 0. We've got our first derivative. Let's let it equal to 0. Okay, when we do that, we let our first derivative that we've found here equal to 0. And what you find, because you've factorized it, it will fall out nicely. If you haven't factorized it and you've left it in this green form here where there's 2 lots of k e to the x, it's not going to fall out nicely for you. So let's let each part equal to 0. We know that k e to the kx can't equal 0. You can think of the exponential curve. It does not cross the x-axis at all, so there's no values there. Then we let our 1 plus kx equal to 0. We solve for x and we get x is equal to minus 1 over k. Okay, so a lot of people got to that, or a lot of people sort of got to that, and you might have got a mark for that. But that's not what we wanted. We need to go further. Let's reread the question. The question asks us where it has exactly one stationary point, and we want to find that the y value is independent of k. Well, we don't have the y value yet, so let's find the y value. Here's my x value, and I'm going to substitute that into my original function. So k is equal to k, and I'm going to, whoops, just in case you can't see what I'm doing there, I'm substituting into this equation here this value. And when I do that, my k multiplies by minus 1 over k. My e has the power of k multiplied by minus 1 over k. You can just see the minus sign in there. These k's disappear. I'll just cross those out. These k's disappear, so I end up with minus e to the minus 1, where it has no value of k, so it is independent of k, and that's what I wanted as my answer. So not a difficult question, but again, you need to make sure that you're looking at the actual function and looking at your function every time when you're differentiating and deciding, hey, does this function have x in more than one spot? Do I need to use the product or the quotient rule? I guarantee that if you do that, you will increase your marks massively, because that's where the majority of people lost their marks throughout this second half of the paper.